Hello, Loyola applicants trying to place out of Algebra 1. Loyola historically has one of the more challenging placement tests. I'm not sure why that is the case. I'm not certain on what they are assessing or why we struggle. But we'll give it our best shot. Many of these things are things that I have taught you. Some of the things are definitely something that we need to continue to challenge ourselves and practice. You'll see stuff that was taught to you in 7th grade, stuff that were taught to you in 8th grade, and things that you may have to do a little bit of enrichment outside of the classroom. So here we go. The sum of 3 consecutive integers is 102. So when we have 3 consecutive integers, we have 3 numbers. So it's 3 numbers added to itself to make 102. And they're consecutive. So if we look at the first number, we're going to say that's our first unknown. So we label it as x. My second number, so if it's consecutive, it's going to be x plus 1. So we're going to give that second unknown x plus 1. And then my third number is not going to be x plus 1 again, because that would be the same number as the second. It's going to be x plus 2. It is 2 spots away from the first unknown number. So we're going to give this spot x plus 2. So we have 3 unknowns. That's my first unknown, that's my second unknown, and that's my third unknown, and they are consecutive, and we're adding them. The sum of them is going to equal 102. So now we're going to simplify the left side. We're going to combine like terms. X, we're going to add all the x's, then we're going to add the constants, and then we get a simple 2-step problem. So a problem that looks overwhelming and confusing, like the sum of 3 consecutive integers is 102, actually is quite easy. So we're left with 3x equals 99. Divide by 3, x equals 33. So x represents my first number, and then we have 33 plus 1, or 34 would be my second number. And then we have 33 plus 2, which is 35. So 3 consecutive numbers that add up to 102 is going to be 33, 34, and 35. That's how we would write them in a solution set. And, oh, sorry, that's not. Write an equation that models this situation. So an equation that models it would be this. And then find the largest integer. So no, we wouldn't put that in a solution set. We would just put 35 in a solution set because it just wants the largest number, 35. Good. Nice. Read the directions is important and understand what they are asking for. Number 2, write an equation of a line that is perpendicular to the line y equals 2x plus 1. So we have this line y equals 2x plus 1, and it has a slope of 2. So if it's going to be perpendicular, is going to be the negative reciprocal. So it's going to be negative 1/2. So the slope of a perpendicular line to that, the slope would equal negative 1/2. So that's an important piece that you need to, and passes through the point 1, 2, or negative 1, 2, excuse me. Good. So if we were going to write that, we could write it in point slope form. So point slope, and why did I pick point slope opposed to slope intercept or standard form? Because notice what we were given. We were given the slope, and we were given a point. So yes, I'm going to use point slope form. And what does point slope form look like? Point slope form, here's the template, y minus y sub 1 equals m times the quantity x minus x sub 1. And we're going to fill in for y sub 1 and x sub 1. Notice the negative is not highlighted. And we're going to fill in for the slope. So let's use that information. Y minus my y sub 1, which is 2. This is my x sub 1. This is my y sub 1. Times equals m, which is negative 1/2, times the quantity x minus my x sub 1. My x sub 1 is negative, different from the negative in the template. And then we can simplify this a little bit. And we get x plus 1. This is in point slope. So this is point slope form of the equation that is perpendicular to y equals 2x plus 1 and passes through the point negative 1, 2. So they want us to give the equation in point slope form. They want us to give it in slope intercept form, and they want us to give it in standard form. Yeah, I love this. A, B, and C are integers, and A must be greater than or equal to 0. Mr. Mack stresses that all the time, and I don't see all too often too many books. There's only a handful of books that point out the A must be greater than must be positive. So we have this point slope form. Let's take that to move into slope intercept form. So slope intercept form, the template is y equals mx plus b, meaning we isolate for y. So if we take our point slope form and we isolate y, let's simplify the right side first. Let's distribute that negative 1/2 into there. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 1 is negative 1/2. And now we're going to add the constant over. And that leaves us with y equals negative 1/2 plus, well, let's do 3/2. I don't want to do a mixed number. It could be equal to plus 1/2, but I like this. I don't mind this. So this is going to be slope intercept form. That's part 2 of your question. And now the third part is take that and put it in standard form. So standard form, the template is A, capital A, x plus capital B, y equals capital C, where A, B, and C must be integers, meaning whole numbers or their opposites, and A must be positive. Those are always the rules that I grew up and that I always teach. So we'll take the slope intercept form. Oh, sorry, I forgot the x there. Negative 1/2 x plus 3/2. And notice that standard form has the x and y on the left side and the constant c on the right side. So we're going to move this x over. And that leaves us with 1/2 x plus y equals 3/2. And now, remember A, so A at this moment is 1/2. It's the coefficient of x. B is the coefficient of y, that's 1. And C is the constant. So we notice that they're not integers at the moment. So we're going to have to manipulate this. How do we get rid of those denominators? Well, if we multiply everything by 2, so that would leave me with 2 times 1/2 is x, 2 times y is 2y, and 2 times 3/2. I wanted that to be in blue, because just to show that you got to multiply everything would give you 3. Now, my A is 1, my B is 2, my C is 3, and my A value is positive. So this is standard form. So these are the 3 equations representing that information. Yeah, you should be able to give this equation in point slope, slope intercept, and standard form. We're good. Write an equation of a line that is perpendicular. Good. So perpendicular, you notice in slope intercept form, notice my slope is negative 1/2. So that's really good. We know we did it correctly. All right. Next page. given line 1 contains the point P, which is in the location 10, 10. So line 1 is this. So this is going to be my line 1. And this is the equation y equals mx plus b. And has the equation y equals mx plus b. Yes, we know that. Hello, just said that. Good. And line 2 contains the point Q, which is 7, 6, and has the equation y equals 2mx plus b. We notice that they share the same, let's make it darker. They share the same y-intercept. So their b is going to be the same. So their b is going to be the same in both equations. So we know that value. Find the values. So how do we do that? Well, we're going to take this piece of information, 10, 10, and we're going to take this piece of information, 7, 6, and we're going to plug it into that equation. That will help us diminish some of the unknowns. So we have these unknown variables, and so this equation y equals 2mx plus b, well, we know that this is a solution, 7, 6 is a solution, so we can put 6 in for y, and we can put 7 in for x, and what do we know about b? Well, we know that they're going to have the same value for b. So let's just hold on to that for a second. Let's simplify that actually. 6 equals 14m plus b. Let's just hold on to that. Let's take the other equation, y equals mx plus b. And that point, we know a point on that line is 10, 10. So we're going to, remember this is my x, y. This is my x and y. So we'll substitute 10 in for y. We don't know what m is. We know what x is. And we don't know what b is. So we get 10 equals 10m plus b. So we're at this stage. Now, we know that their b values will be the same. So I know that these, so if I solve for this equation, this left equation for b, if I subtract 14m, we have negative 14m plus 6 should equal b. And if I subtract 10m from both sides, we get negative 10m plus 10 equals b. And now we can use the fact that we know that b equals b. B from equation 1 will be the same as b from equation 2. So I'm going to take this statement. Was that yellow or green? That was green. We're going to take this statement and we're going to substitute it in for this b. And we're going to take this statement and plug it in for the equation here. I think I maybe did that wrong. That should be, sorry, those numbers should be reversed. Oh, that was not, I didn't want to erase all of that. I just wanted to erase a little bit of it. And I want to make this, because this is technically line 2 and line 1. So we have negative 14m plus 6 equals negative 10m plus 10. What's the beauty of it? We only have one variable. Yeah. So let's move the variables to one side. And let's move the constants to the other. So we get negative 4 equals 4m. How come that doesn't seem like it's going to work? Oh, no, that's good. Divide by 4, divide by 4. We get negative 1 equals m. So clearly, this is not drawn. Oh, m is my slope. So that's my slope. My slope is negative. Would those lines have negative slopes? Oh, yeah. And then the other one is 2 times m. So it's going to be twice as negative. Yeah. So that is a slope of 1. Yep, that makes sense logically. I'm just checking for reasonableness. So now what is the question? It says find the values for m and b. Okay, so we know m equals negative 1. And if we want to find b, then we can go back to either of these equations and we can plug in for m. I'll use the yellow one, negative 10m plus 10 equals b. Let's plug in negative 10. M is negative 1. And we get 10 plus 10 equals b. 20 equals b. So my y-intercept, that value is 20. Seems reasonable. Again, you have to be careful. Not everything's always drawn to scale. And hey, what if we use the other equation? What if we use the green equation, negative 14m, negative 14m plus 6 equals b, I think it was. What if we plug that in? Negative 14 times 1, negative 1 plus 6 equals b. 14 plus 6 equals b. 20 equals b. So it gave me the same answer because the b value should be the same. So we get the correct answer is that m is going to equal negative 1 and b is going to equal 20. Fun question. Fun question. Okay, and look, you have to know all of linear equations to be able to apply that, to be able to manipulate it, to be able to answer not just the straightforward question, what's the slope of a line? What's the y-intercept? That's just very vanilla basic. And these placement tests are going to ask you a deeper question. And they want to see how deep is your comprehension. You can't just know it just to regurgitate it on a test one day and then forget it. I continue to tell you, you need to know this inside and out. You have to spend time. You have to do word problems. You have to do more. You have to go above and beyond of what is being asked of you. Can't do a minimum. You have to do above and beyond. Much like your sports, you don't just go to practice. You do privates. You go on the weekend. You practice after school. You get all this stuff. You join multiple teams. Same concept. If you want to be successful in academics, you do the same things that make you successful in athletics. Tom has a collection of 30 albums, and Nita has a collection of 18 albums. Tom is adding an album a month to his collection, while Nita is adding 5 albums a month to her collection. Write and graph a systems of equations. So we're going to write 2 equations to find the number of months after which they have the same number of albums. How many albums will they each have at that time? So we have to write an equation for each of the situations. Tom has a collection of 30 albums. Tom is adding an album a month to his collection. Nita has a collection of 18 albums. Nita is adding 5 albums a month to her collection. So let's deal with Tom first. Tom has 30 albums, and he is going to add 1 album a month. And that is going to equal his total. Nita has 18 albums, and she is adding 5 albums a month. Notice it's 1 album a month. I didn't write the 1 because that's just not a good. And if we add that, that would be her total. Notice we use the same variables. M represents month, T represents total, and we were able to write 2 equations. Now we're going to use write and graph a system. So they want you to graph this. Understand that this equation can be seen as y equals x plus 30. And we understand that this representation would be y equals 5x plus 18. Substituting y for t, m for x, or x for m. And now we have 2 linear equations. So we could graph that on a chart. It's not going to be great only because I don't have 30 spaces or 18 spaces. So that's going to have to be a little bit bigger. I wonder if I could change that to make it 20 spaces or 30 spaces. Does this have the ability? Properties. No, line style. Does that give me? Oh, what's this going to be? Lock, link, sound, properties. Yeah, we already did the properties. Fill effects. Oh well. I thought maybe it might. No fill. No fill. Yeah. I always wondered if there was one with more of a... Ooh, let's do... Sorry, I know that we're on a tangent. Coordinate plane with 30. 30 by 30. Is that 30? No. Is that 30? Oh. Welcome, graph paper. Oh, math drill, 4-quadrant paper 30. Yes. Paper, where is it? Print. Okay. Oh, and I can grab it. Okay. Okay. Let's take that away. I know. Well, this is what we do. Okay. That's not bad. We technically, it's a little grainy, but we got it. So, oh, we're pivoting. Sorry. So let's take this equation, and this. Let's do this one. This is Tom's. Tom has a y-intercept of 30, so y-intercept of 30 right there, and a slope of 1. So it's up 1, right 1, up 1, right 1. So he's adding an album a month, shall we say. And so every month he's increasing his album total by 1. And that will go on forever. Now let's look at Nita. Nita has a y-intercept of 18, which is right there, and she's increasing by 5 every month. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we see that's where they are going to 1, 2, 3, 4, 5. That's where they're going to intersect. So their intersection point, and how you do that on a test through graphing, is probably very hard. So 1, 2, 3, after 3 months, because our x-axis is months, because remember M went in for X, and our y-axis is albums, or totals, no, totals, album, total, album, totals. So, and how many albums will they have? They will have 30, 31, 32, 33 albums. I didn't spell albums right. Albums. That's a weird word. You okay with that? So that is write and graph a system. So we wrote and graphed, find the number of months after which they have the same number of albums. So after 3 months, they have 33 albums. How many albums will they each have at that time? They will have 33 albums. And bonus question, when will Nita have twice as many albums as Tom? Woo! When will Nita have twice as many albums as Tom? So we'll do that in a second. You also know that we could have set these equal to, and you could have had, this is y equals x plus 30, I think was Tom's formula, x plus, and Nita's was y equals 5x plus 18. When we do systems, you set each one equal to each other. So we, again, are going to substitute those in for, this is y for Tom, and this is y for total for Nita. So we get x plus 30 equals 5x plus 18. We're going to move the variables first. We're going to move the constants to the other side, and we get 4x equals 12, divide by 4, 3 equals x. Remember, x represented months. That's not how you spell months. Months. So after 3 months, and so that would have given you the number of months, and then you plug it back into either of them. If you plug it back in, 3 months, so y equals 3 for x, because x represents months, we get y equals 33, and this is the total albums. Total albums, and that is how we would have gotten the second part. So without graphing, this is a nice way of being able to see how to get to those answers if you don't have a 30 by 30 graph. So either way, through graphing or through using systems, you either do substitution, you do addition, multiplication, you know all the different techniques of using systems of equations. Now, if we want to know when will Nita have twice as many, what we're really saying is, hey, when does twice Tom's value equal Nita? When will Nita be twice as much as Tom? So you do 2t equals n. So when will twice of Tom equal Nita? So we can again go back to those equations. So you have 2 times x plus 30 equal, and Nita's we don't have to manipulate, 5x plus 18. And so we get 2x plus 60 equals 5x plus 18. We're going to move the variables. We're going to move the constants. And that gives us 3x equals, and that's going to give us 42, divide by 3, we get 14 equals x. So after 14 months, Nita will have twice as many albums. I always want to put an M, twice as many albums. How many will that be? Well, you can plug it in. Plug it in. 5 times 14 is going to be 70 plus 18 is going to be 88. Nita will have 88. We'll have 88 albums, and Tom will have 44 albums. If she's going to have twice as many, and we can check to see, hey, after 14, does Tom have 44? So let's go back to Tom's equation. Y equals x plus 30. So what's 14 plus 30 is 44. So it checks out. Great problem. Again, really, really good for you to understand and comprehend a deeper question. Johnny Cub throws a baseball straight up in the air. Here's Johnny Cub. Hey, Johnny Cub with his baseball mitt and his baseball. He's going to throw that baseball. Let's do this. Here's his baseball. He's going to throw that baseball up in the air. Straight up in the air. So he's going to... You like that sound effect? The height and feet of the baseball can be modeled by the function h of t equals negative 16t squared plus 128t, where t is the measure in seconds. What is the maximum height reached by the ball? How long after the ball leaves Johnny's hand will it reach the ground? You should be able to solve for the time needed for the ball to reach the ground in 2 different ways. I don't like this question. This question is wrong. You can let the Loyola math people know. This is assuming that Johnny Cub is on the ground, because this ball is going to actually start in his hand. So technically, that ball is not on the ground. So it's going to start in a different place than when it's going to land. So it says, when, where is teammate, or what is the maximum height? How long after the ball leaves Johnny's hand will it reach the ground? Well, so the maximum height is fine, but this formula says that at time 0, if you plugged in 0 for time, notice what height is. Height would be 0. So that would mean that the ball at time 0, we're assuming this is time 0 when it's in his hand. Once he throws it, time starts. So this is making a horrible assumption, because that ball, if Johnny's holding the ball, he's not on the ground. So this is a bad question. Well, it's not a bad question. It's a great question. It's the wrong formula. There should be a constant here. It should probably be plus 5, because, well, maybe not 5, maybe 4, because he's 4 feet. When he's holding the ball, he's 4 feet above the ground at time 0. So that's a bad problem. Maybe I should email them. No. So at time 1, 2, 3, 4, and then we'll reach a maximum height 5, 6, 7, 8. So we want to know both of these places. We want to know when it hits the ground and when it's at its maximum height. So we need to understand the path of a ball. A path of a ball is, yes, you know what that is? That's a parabola. Yep, a parabola. It's called a parabolic path. Even when you throw it straight up and down, it still has a parabolic path. And parabolas are symmetrical. So we're going to utilize the symmetrical part. And there is a formula. This h of t equals negative 16t squared plus 128t is in a quadratic formula, ax squared plus bx plus c. So in order to find the what would we call it? The axis of symmetry, axis of symmetry, our x value is going to equal the opposite of b over 2a. So if this is my b value, this is my b value, this is my a value, and my c value is here, but that's 0, but that doesn't come into play here. So my opposite of b is negative 128 over 2 times a, which is negative 16. So x is going to equal negative 128 over negative 32, which equals 128 divided by 32, which gives us 4. So my x value is 4. So remember, this is t-axis for time. This is h-axis for height. So after 4 seconds, that ball will be at its highest point. That's what we're finding, the axis of symmetry. That's the red. And the nice thing about the red is that is the, at this point is the max. Okay, it's the vertex. And because it has a negative coefficient of a, we know that it's going to be upside down. So the axis of symmetry tells us the time. So after 4 seconds, it's going to be at its highest height. The height in feet, what is the maximum height reached the ball? So I know the time when it is, so I'm going to plug it in for t. So if I want to find the height, h of 4, meaning the height after 4 seconds, I'm going to plug in 4. 4 squared plus 128 times 4. So t, or x, is going to be plugged in there. H of 4 equals negative 16 times 16 plus 32, 0, 502. Let's make sure. What are we multiplying? 128 times 4. 128 times 4 is 512. Duh. 512, Mr. Mac. And 16 squared gives us 256. So h of 4 equals negative 256 plus 512. And that gives me h of 4 equals 256 feet. So after 4 seconds, the ball will reach its maximum height of 256 feet. How cool is that? That's so cool. This is why I love algebra. This is why I love Algebra 1, because the tail end of Algebra 1 are parabolas. Now, not often do Algebra 1 8th grade courses get to parabolas, and especially graphing, especially really fun word problems like this, but you will definitely do this in Algebra 2. And physics. Here's physics, big time for you. All right, so that's the first part. How long after the ball leaves Johnny's hand will it, oh, sorry, no, that's the second part. We're on the first part. What is the maximum height reached by the ball? So we just figured that out. After 4 seconds, the ball will reach its maximum height of 56 feet. So here's the next question. How long after the ball leaves Johnny's hand will it reach the ground? So what do we know about when it reaches the ground? Well, Mr. Mack, it never was on the ground. You're right, but we will do, and that's the cool thing is math. We want to know when height is 0. When that ball reaches the ground, the height is 0. So we can fill in for the height. When does height equal 0? So we have a second part to this equation, or to this problem. When is the height 0? So we plug in 0 for it. We have negative 16t squared plus 128t. So how do we solve? Well, remember, is it set equal to 0? Yes. Is it in standard form? Yes. Is there a common factor? Yes, there is a common factor, negative 16t. So we're going to factor that out. That gives us t minus, what's 128? 128, I think it's 4, right? No, divided by 16, what do we have? 8. 8. Okay, so, oh yeah, hello, I should have known that. I'll show you why we know it was 8. So now we have the product of two things that equal 0. We're using the 0 property. We know that one of these must be 0, so we set each one equal to 0. And we divide by negative 16, divide by negative 16, t equals 0. Add 8, t equals 8. So at time 0, it will be on the ground. It will be on the ground. And this is where we get a problem, because we know at time 0 it's in his hand. So time 0, it is not on the ground because they messed up. That's where this problem is wrong. At time, that's 0 seconds. At time 8 seconds, it will also be on the ground. Hit the ground. So that's why that formula was incorrect. Because we know if it's in Johnny Cub's hand, it's in his hand, and his hand doesn't look like it would be on the ground. I don't know how many people throw a baseball from the ground, but technically, because they made a mistake, technically at time 0, they're making the assumption, because this has a y-intercept of 0, so we're saying that at time 0 it's on the ground in 8 seconds. How did I know that also before doing that? Well, if the midpoint is 4 seconds and it's symmetrical, I could just double the axis of symmetry to get 8 seconds. And yeah, that makes sense, right? If it takes the same amount of time to go up as it does down because of gravity, yeah, I could have probably solved that without it. But this is important. This is good. So after 8 seconds, it will be, you might want to pass that along, that it's incorrect equation. But we are on lots of tangents. Problem number 6, here we go. You should be familiar with this. We did this earlier in the year, chapter 2, I think it was. Remember, we must isolate the absolute values first. Many of you made that mistake, so we want to divide by -7. We get the absolute value of 2 minus 5a. We also have to remember that we divided both sides by a negative. That means we must flip the inequality greater than, and that's going to be +8. We have isolated the absolute value. Now we're going to create two statements. We have 2 minus 5a is greater than or equal to 8, and we have 2 minus 5a is less than or equal to -8. Since I made it negative, we have to flip the inequalities again. Now, is it an and or an or? This is greater than or equal to, so we know that this is going to be an or statement for my solutions. Remember, compound inequalities produce ors and ands. If it's greater than, it's an or. If it's less than, it's an and. Now let's solve each of these sides. -5a is greater than or equal to 6. Divide by -5. We again have to flip the inequality one more time. Those little sneakies. -2 minus 2, -5a is less than or equal to -10. Divide by -5. A is greater than or equal to 2. And remember, this is an or, so if we graph this on a number line, we have -6/5, we have 0, we have 2. So if we're going to graph this one, A is less than or equal to, closed, going to the left. And then if we were going to graph this, this is closed circle also, greater than or equal to, going to the right. Or we need at least one true, at least one true. We can have more than one, but where is there at least one true? So this is the graph of the solutions. That would be the proper way to graph the solutions to this inequality. Solve and graph your solutions. Boom. I have videos explaining all this. For all of these questions, there is lots of, I have over 300 videos on my YouTube channel that you can refer to, even parabolas, even Johnny Cub problems. So go take a peek and look at my parabola work and solving and graphing parabolas. It'll help you. We love this. This is very relevant to what we're doing. Simplify the rational expression, state the excluded values. We cannot cancel things being added, adding and subtracting, so we have to turn them into a product. So we're going to turn these into two binomials. Let's take x squared minus 2x minus 24. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? Is it a binomial square or the difference of square? No. So we're going to do a times c. A is 1, c is -24. Factors of -24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different, and the bigger is negative. So negative, 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 negative. Signs are different, signs are different, signs are different, signs are different. That gives me -23, -10, -5, -2. Which one equals my middle? Which one equals my middle? This does. So +4 and -6 are going to be my outside and inside. So I'm going to rewrite this trinomial to make it a polynomial. X squared plus 4x minus 6x minus 24. I'm going to factor by grouping. I'm going to group the first two and the second two. If we factor out an x, we get x plus 4. We factor out a -6, we get x plus 4. And I did it right because I have the same binomial. I'm going to factor out an x plus 4. If I take that away, I'm left with x minus 6. So that turns into the quantity of x plus 4, x minus 6. We could check and make sure. First, outer, inner, last. Yep, that produces that trinomial. Let's do the other trinomial, x squared minus 5x minus 36. Standard form, yes. Common factor, no. Special case, ooh, 3 terms. Is it a binomial square? It's 3 terms. Oh no, my third term is negative. So binomial squares, because 36 is a perfect square and x is a perfect square, we know that special cases, our first and third must be perfect squares, but 36 is negative, so we know it's not a binomial square. So we will go to a times c. A is 1, c is negative 36. Factors of negative 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 no, 6 and 6. Signs are different again. Bigger is negative again. So negative, 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 positive, 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 positive. Negative 35, negative 16, negative 9, negative 5, and 0. Which one's equal to my middle? That would be positive 4 and negative 9. So this becomes x squared plus 4x minus 9x minus 36. Factor by grouping, factor by grouping. You get x times the quantity x plus 4. Factor out a negative 9, x plus 4. So we take out the x plus 4, and we get x minus 9, and that becomes x plus 4, x minus 9. So because these are being multiplied, I can cancel them. I cannot cancel these when they're being added and subtracted. I can't simplify those because they're being added and subtracted. That's the mistake that most students would make at this stage. And so my answer, simplifying, is x minus 6, x minus 9. That is my answer. We can't cancel the x's. We can't simplify the negative 6 and 9 because those are being added and subtracted. Now they talk about excluded values. Those are values that would make the denominator 0. So if we look here, what value for this binomial would make that a 0? Negative 4? Good. So the excluded is negative 4. And what value would make this binomial 0? A positive 9, yeah. So those are the two values that we cannot have for x. Because if x is negative 4 or positive 9, it would put 0 in the denominator, and we can't have 0 in the denominator of a fraction. So your two parts is x minus 6 over x minus 9 is the simplified, and then the excluded values are negative 4 and 9. Yep, there you go. So x cannot equal negative 4 or 9. Solve for x. So when we want to solve for x, we're going to isolate. In this case, we're going to isolate the radical. So we're going to move the 4 over. We get x minus 4 equals the square root of 3x minus 8. What's going to get rid of a square root? Well, let's think about it. What got rid of addition? What's the inverse of addition? Subtraction. What's the inverse of subtraction? Addition. What's the inverse of multiplication? Division. What's the inverse of division? Multiplication. What's the inverse of a square root? Squaring. Yes. So if we want to get rid of a square root, we need to square. And what we do to one side, we have to do to the other. And yes, we just introduced, yep, Chewbacca. We can't just square the 4. We have to square the quantity of that. So let's think about that. That's a binomial square. Remember, this is equal to this. We would not square each individual. We can't distribute the square into that. So this produces x squared minus 16 minus 8x, Mr. Mac. 8x plus 16 equals, now this square and the square root are going to cancel, and that leaves us with 3x minus 8. Yes, you like that? Now let's set it equal to 0. So now we've got x squares, we've got x's, so set equal to 0. We'll minus 3x. Minus 3x. We'll add 8. Add 8. We get x squared minus 11x plus 24 equals 0. Now we're going to look for a common factor. Oh, no. Is it in standard form? Yes. Is there a common factor? No. Whoop. Is it a special case? Is it a binomial square or the difference of square? No. So we have to do a times c. A is 1, c is 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are the same, and they're both negative. So negative, 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 negative 25, negative 14, negative 11, negative 10. Which one's equal to my middle? Negative 11, that's this. So I'm going to take these two as my outside and inside. X squared minus 3x minus 8x plus 24 equals 0. Let's factor by grouping. We're going to factor out an x. You get x minus 3. We're going to factor out a negative 8. You get x minus 3 equals 0. X minus 3, x minus 8 equals 0. We're going to use the 0 property. Remember, when you multiply two unknowns to make 0, one of those, 1 must be 0. It's the only way you can get 0 through a product. Either this box has to have a 0 in it, or this box has to have a 0 in it. So here are my two boxes. I'm going to take this box and ask the question, what value for x would make it equal to 0? I'll add 3 to. So when x is equal to 3, yeah, hello, that box would be equal to 0. And then you have x minus 8. We set this equal to 0 in order to ask the question, what value for x would make that 0? 3 and 8. So those are my solutions to this problem. How crazy is that? Oh my goodness. And we might want to check. 3 times 3 is 9, minus 8 is 1, square root of 1 is 1, 4 plus 1 equal, that's an exclusion. Boom, that's excluded. Thank goodness we checked. Let's check. Check our answer. X equals, what is it? 4 plus the square root of 3x minus 8, I think it is. Minus 8, yeah. Oh, I didn't know we had exclusions. Silly Mr. Mac, if we plug in 3. Yeah, right? Yeah, 3 equals 4 plus square root of 3 times 3 minus 8. 3 equals 4 plus the square root of 9 minus 8. 3 equals 4 plus the square root of 1. 3 equals 4 plus square root of 1 is 1. Does 3 equal 5? No. So 3 is an exclusion. Because it, yeah, well, because it, let's check the other value. Let's check 8. Let's do x equals 4 plus square root of 3 times 8 minus 8. Oh, not x, 8. Does 8 equal 4 plus? 3 times 8 is 24 minus 8. 8 equal 4 plus 24 minus 8. Is that 16? I think that is 16. And square root of 16 is 4. Does 8 equal 8? Bing, bing. So we only have one solution, just 8. Mr. Mac did not know that. He wrote a wrong answer on his initial problem. So I'm glad I checked. That's what checking gets you, kids. So we found out that there's an exclusion. Perfect. Love it. Check your answers. Number 9. And there are lots of problems like number 8 on my website for a for a low price of free. we have radicals. When we have radicals in the denominator, we can't have them. What gets rid of a radical? What gets rid of a square root of 3 is another square root of 3. Because we would have the square root of 3 quantity squared, the square and the square root, and that's why any radical times itself will get rid of it. The problem with that, if we had something like 3 over the square root of 6, how do we rationalize it? By multiplying by the radical 6 over radical 6. This is a value of 1, so we're not changing the value of the fraction. And you get 3 rad 6 over 6, and then we would simplify the outsides. You would only be able to do outside with outside, inside with inside. So this gives you rad 6 over 2. And we cannot simplify the 2 and the 6 because the 2 is on the outside, the 6 is on the inside. So this is called rationalizing. Now, the challenge of this is we have a binomial in the denominator. And so rationalizing is a little bit more complex, not as easy. So we can't just multiply by, we can't multiply it by rad 3 plus 4 rad 2. We can't multiply it by itself because, yeah, that would get rid of it. And yes, this would, but remember FOIL, we have our outside and insides and we'd still have radicals. So how would we be able, what do we multiply in order to get rid of that outside and inside? Did you say conjugates? Yes. Remember, conjugates get rid of the outside and inside. So when we rationalize binomials in the denominator, we're going to multiply it by its conjugate. And what we do to the numerator, we have to do to the denominator in order to keep it as a value of 1. We're going to do 3 distributed into that, which gives us 3 rad 3 minus outside, outside. So negative 12 rad 2. Now let's talk about foiling this. Rad 3 times rad 3 is going to give us rad 9 or 3. Any radical times itself pops out. Then we're going to distribute that to this. So rad 3 times negative 4 rad 2. We're going to combine the radicals, rad times the rad. So we get negative 4 rad 6. And then we're going to multiply 4 rad 2 times rad 3, which is positive 4 rad 6. You see that the outside and inside are going to cancel. That's why we did the conjugates. And then we're going to multiply 4 rad 2 times negative 4 rad 2. Outside with outside, negative 4 times 4 is negative 16, excuse me. And we have to do the radical. Don't forget the radical. Rad 2 times rad 2 is 2. So this simplifies to 3 rad 3 minus 12 rad 2. We can't combine those, different radicals. So radicals are very similar to variables. And these cancel, they cancel. And then we have 3 minus 32, which is negative 29. Now, no number cancels with, so that would be our answer. 3 rad 3 minus 12 rad 2 over negative 29. You may see, there's no, negative 12 rad 2 plus 3 rad 3 over negative 29. I don't think that there is a standard form with radicals, whether it has to be numerical order. I don't know. But either one should be fine. So that is rationalizing. Number 9, that was A. This is number 9B. Also, lots of examples online for this. When we have radicals, when we have to simplify them, we're going to put them under their own house. So we're going to separate those. And we're looking for perfect square factors in each of those. So I know that 4 is a perfect square. So I know 4 goes into 320 80 times. Why did I choose 4? Because the square root of 4 is a perfect square. It becomes 2. Now 80 I still have to simplify. and I know that 4 goes into 80. So I'm going to do that because I wanted to do a perfect square. So I have 7 times 2. Square root of 4 is 2. And rad 20 can still be broken down. I can still simplify that. And why did I choose 4 and 5 and not 2 and 10? Because 4 is a perfect square. So 7 times 2 times 2 times 2 times rad 5. So that is going to be 56 rad 5. Okay, so that's outside, insides. Now, rad x to the 5th. Remember, we can write this as that. Why did I break them into squares? Because if I put it under its own house, this is going to produce times x. This is a perfect square, so it produces x. This can't be simplified, so it just stays as rad x. So this is going to be x squared rad x times x squared rad x. Now let's do the y's. And this one, we again, y to the 8th, I'm going to make that y squared, y squared, y squared, y squared. That, now we're going to put them under their own radicals, because we can separate radicals being multiplied. We cannot separate radicals being added or subtracted. So multiplying, dividing, we can separate them into their own houses. That's going to produce y. 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 So we get y to the 4th. Now, we're going to put all the outside stuff, outside, outside, outside. So we'll write that as 56x squared y to the 4th. And then we have inside and inside. So we're going to write that under the same house, 5x. And that's how you simplify radicals. Yeah, lots of work. Yep, perfect. Number 10, again, very familiar. We've done plenty of simplifying and lots of exponential work. First thing we need to address is the exponent. We have to simplify this into that, and we know the power of a power we multiply. So that is x to the 4th times 4 times y to the negative 3 times 4 times 2 times x times y to the 4th over x to the 2nd times y to the 4th times z to the 3rd. Let's continue to simplify the numerator. We could do it all in one fell swoop, but we're going to, so we get x to the 16th, y to the negative 12 times 2 times x times y to the 4th all over x squared y to the 4th z to the 3rd. Let's continue to simplify the numerator. We have like bases, so we are going to add their exponents. That gives us x to the 16 plus 1. Let's put the 2 out there in front because that's not being affected by anything. We're going to work in alphabetical order. We have y to the negative 12. Like bases, we add their exponents even if they are negatives all over x squared y to the 4th z to the 3rd. Let's simplify that. 2x to the 17 y to the negative 8 over x squared y to the 4th z to the 3rd. Now we're going to combine through division. When we divide like bases, we're going to subtract their exponents. So that's going to equal 2x to the 17 minus 2, y to the negative 8 minus 4, all over z to the 3rd. That doesn't have a partner, so we're just going to keep it down there. So we also had our y had like bases. Now let's simplify. Let's do those subtractions. So you have 2x to the 15th, y to the negative 12 over z to the 3rd. You could leave that as an answer, but it says only positive exponents. So I need to move this. This has a negative exponent. When you want to get rid of a negative exponent, when you change the sign of the exponent, you change the location of the base. So 2x to the 15th, and now that y to the negative 12 goes to the denominator and becomes a positive exponent. Z to the third was already down there. We are done. So lots of good stuff right there for you to comprehend. Lots of problems on the website. Last one. Last one. Here we go. In the figure below, you see a square inside a rectangle. So we know this is a square. So we know that this distance, or this length, is 2x plus 7. Express the area of the region inside the rectangle. So they're talking about, this is a little bit tricky, express the area of the region inside the rectangle. So we're talking about this space, okay? But outside the square in terms of x, yes. All right, so how do we get that? That's sort of like a donut. And a donut, how do we express the donut piece? Well, the way to get the donut is to take the dough and subtract the nut. So you take the outside and you subtract the inside. So that's what we're going to do. Oh, we got some values that are still there from earlier, sorry. Delete, delete, delete. All right, so we have the donut is going to equal the whole minus the part. So the whole is going to be, so we need the area, area of the shaded is going to equal the area of the rectangle minus the area of the square. So we know area is length times width minus area of a square is length times width also. You could do side square also, but we'll just do this since we have it. So the length of the rectangle is 6x minus 1. So 6x minus 1 times the width is 4x plus 3 minus the area of the square, which is 2x plus 7 times the width, which is 2x plus 7. And we have to do this multiplication before we do that subtraction. So let's FOIL these. That's 24x. That's plus 18x minus, plus 18x minus 4x minus 3, which gives us 24x squared plus 14x minus 3. Now let's FOIL these. That's minus. That's going to be 4x squared plus 14x plus 14x plus 49 minus 4x squared plus 28x plus 49. And now we're going to distribute that negative to all three terms. I see way too many students not distributing all of them. So we have 24x squared plus 14x minus 3 minus 4x squared minus 28x minus 49. Let's combine like terms. We have x squared and x squared, which makes 20x squared. We have 14x and negative 28x, which is negative 14x. And we have negative 3 and negative 49, which is negative 52. So the area of the shaded region is going to equal 20x squared minus 14x minus 52. Oh yeah! There, kids, is your answers. And those are all your answers. Yeah, see, 8 excluded. Number 8, x is only 8, not 3. That was a good catch. Everything else should be good to go. You should be able to solve. Reaches 8 seconds after it leaves Johnny's hand. Bad question. Bad problem. I think I'm going to call math department. I'm going to email them. Let them know that there's a mistake there. All right, good luck on your placement test. You are going to do a great job.
Thanks for playing along.